Hi, in this video, I'll be doing this problem from the JEE in India from August 2021. The JEE is short for Joint Entrance Exam, which is the examination given by the top engineering universities in India for admission. Well, this is a physics problem, not a math problem, but there's an element of math skills in it. So that's why I'm doing it. The question is, in the given figure, the EMF of the cell is 2.2 volts and internal resistance is 0.6 ohm. Calculate the power dissipated in the whole circuit. And you have that circuit. It has an OR here, a massive configuration of more ORs, more resistances there, and you're given that the voltage is 2.2. And you asked for power. Well, power P is given by V times I, and I is given by Ohm's law, is V over R. So you plug it in here, you get V times V over R, or V squared over R. Well, V is given. So really, we're only looking for R. Well, what you have is a small R inside the battery in series with whatever massive configuration is between A and B. So let me just call all of this R subscript EQ for equivalent. Then R is equal to real R plus R EQ. So all we need to find is R EQ, and we plug everything in and we're in business. All right, now you have a configuration with like resistances crossing over each other, but it's actually a very simple object mathematically. It's what we call a planar graph. We can flatten it so that nothing crosses over anything. You have resistances that look like they're crossing, but if you twist them, then they just flatten out. That's what's going to happen with those diagonals. But if you cannot visualize the untwisting of the diagonals, here's something you can do that works almost all the time. First of all, let's take a look at point A. This entire branching off has no components in it. That means all of it is just like one point. So all of this is point A. And the same thing on the right. All of this is point B. Here's the key. When you have things like that, try to imagine going from A to B. What are all the different ways you can go from A to B? A on the left, B on the right. The first way you can go is directly through the edge on top. And that's a single resistor of 4 ohms. The second way you could go is on the downward diagonal. You could go from this point to that point. So that edge consists of 2 resistors of 4 and 8 ohms. A third way is to go on the upward diagonal. That is also a way of going from A to B, and it consists of 2 resistors, 2 and 4. And finally, you have the edge at the bottom. And that's another single resistor of 8 ohms. So you have that massive crossing over thing, but once you've untwisted it and flattened it out, it's a nice, what we call in math, a planar graph. That's just parallel resistors. So the equivalence for this parallel follows the invert rule. So it's 1 over 4 for the top. The second line is 1 over 12. Third line, 2 plus 4 is 6. Last line, 8. Common denominator is a 24. And the numerators are 6, 2, 4, 3. For a total of 15 over 24. And simplify, you get 5/8. So that means the equivalent resistance is 8/5, or 1.6 in decimal. So the total resistance of the whole circuit is 0.6 plus 1.6 equals 2.2. Plug that into the power, and we know the voltage is 2.2, so P is 2.2 squared over 2.2, which is 2.2 watts. That's it. Hope you had fun. Any questions? Please leave in the comments. Like and subscribe for more contents, and thanks for watching. Bye.